Okay, so let's look at this question. Calculate the mass of silver deposited when a current of 2.5 ampere is passed through a solution of silver triazonitrate 5 for 1 hour. So what are we asked to calculate? The mass of silver deposited. So we're looking for mass in gram. When a current, we are given the current to be 2.5 ampere, is passed through a solution of this for time is what? 1 hour. So this 1 hour, we are going to convert it to seconds by multiplying by 60. And that is going to give us 3,600 seconds. I hope we understood this. Okay, then the next thing to do is what? We are asked to find the mass of silver. So which formula are we going to use? This. So this will be mass over molar mass is equals to IT over CF. So this is what? That's what we are looking for. Molar mass is what? 108. Current 2.5. Time 3,600. All over charge. Now remember what I told us, the electrochemical series I told us on the first video on electrolysis. Please go and memorize it. I beg you, please. Okay, so the charge of silver is 1. Multiplied by what? Farad. Farad is what? 96,500. Please go to my first video. Go to the first video on electrolysis and watch the video to the end so that you will see where I put down the electrochemical series like this. Please note the charges and have it offhand. Have it by heart, please. It's going to help you in this topic. Okay, so we are going to cross multiply. And when we cross multiply, what do we have? M times 1 times 96,500 is equals to 2.5 times that's 3,600 times 108. So this person has the coefficients. We are going to divide by over 1 times 96,500. So this is going to cancel out this and we are going to multiply this. So let me get my calculator. We are going to multiply that and that will be and that will be 2.5 times 3,600 times 108. That will give us 97,200. 972,000. This will give us this over 96,500 divided by 96,500. And that will give us 10.07, which is what? 10.0, or which is 10.1 gram, approximately to the nearest to 1 decimal place, approximately to 1 decimal place, or you can still leave your answer like this, depending on what the options gave you. Your answer here is directly proportional to what your options gave you. Okay, let's look at another question. Okay, so let's look at this question. 0.22 gram of a divalent metal is deposited when a current of 0.4 ampere is passed through a solution of its salt for 25 minutes. Calculate the relative atomic mass. So let's write out our parameters. What is this? Mass, because it is in gram. So mass is 0.222 gram of a divalent. Divalent tells you that the ion of that metal is what? 2. So what would that be? C, which is charge, is 2. Is deposited when a current is what? Is passed through a solution of its salt for 25 minutes. Time is what? You are going to multiply to 6 by 60 in order to convert to what? Seconds. So what would this be? 1,500 seconds. Are we together? Okay. So the question says we should calculate the relative atomic mass, which is the big letter M. So which formula? We are going to use this formula. Remember, this represents molar mass or relative atomic mass. Are we together? Okay. So let's solve. M over N is equals to IT over CF. This is what? Mass, which is 0.22 gram over, we are looking for the relative atomic mass, and then I is what? I is 0.45 times T is 1500 over C. C is the charge. The charge, they told you, is divalent, meaning what? 2. And then Farad. Farad is what? 96,500. So we are going to cross multiply, and we have that times 2 times 96,500 is equals to 0.45 times 1,500 times M. So let's divide both sides by the coefficient of this. 0.45 times 1,500. 0.45 times 1,500. Cancel, cancel. So let's solve. Calculator. Let's solve. 0.22 times 2 times 96,500. 96,500. That will give us 42,846 divided by 0.45 times 1,500. That will give us 675. So you have that 42,846 divided by 675. You have what? 63.475. So this is 63.5 approximately. Isn't that simple? So the metal, whatever the metal is, this is the relative atomic mass. Isn't that simple?